Hello and welcome to the training session regarding the Moose framework. In this session we are going to explain and we are going through a new class. It's called the AIBALANCER class. The AIBALANCER class main purpose is that it serves servers in the multiplayer environment may have certain clients not being occupied by players. So a mission may seem very empty when players join, and you don't want that. So the AI Balancer provides the functionality to balance the battlefield with active AI units, which are compensating those client slots not being occupied by players. So when you look at the AI Balancer object, it actually uses three different objects of other classes. The first object is a set client, which is a set of clients. And by the way, the clients are actually automatically scanned within the database object. So the set client class, when you instantiate this will use the database class, and you can filter the set client populating those clients that you want to have within the set client with filter criteria. The next one is the spawn class or spawn classes, which we all know, which are actually responsible for spawning the AI to be active within the AI Balancer. And then you have an optional patrol zone that allows you to have the AI that's being spawned compensating a client to be patrolling a zone. Let's go to the AI Balancer detailed functional overview. So, as we already said, spawning. It will spawn AI groups providing replacement for client groups that are not occupied with players and thus are not alive. The second one is when an AI group needs to return, meaning when a player is joining a client slot, then that AI will return to an airbase. And you have two options there. You can select that the AI will return to the airbase on the current route, or you can let him return to the nearest friendly airbase, excluding the neutral airbases. So it will really select the friendly airbase. The third function is that when a player jumps into a client, then that client group will be created with the player in it. So the AI will only return when there is no enemy client within a certain range in the neighborhood. So function 2 will only be executed when function 3 is when the function of 3 is invalid. Function 4, as already said, you can let the AI patrol a given zone instead of following the route already outlined to the AI group. You can select between multiple patrol zones, so you can select the patrol zone that you want, and when the AI group is out of fuel, a new AI group will be spawned automatically and will be on its way to the patrol zone. So this allows you to have continuity within the patrol zone, and the old AI group, which has empty fuel, will wait until the new AI group has arrived using a time stamp. The fifth function is that you can let the AI Balancer randomize between different spawn objects, meaning that you can randomize the routes to be followed by the AI groups, and you can also randomize the sets of groups templates. So look at the notation here. I'm going through different symbols in a while. So this is a client, and if the client is joined by a player, it will be indicated here as player. Here I will have an AI in the light blue color. An airbase is in the color of the coalition, which is blue for the blue and red for the red, and a client and an AI for the red. So let's go to function 1, spawning AIs. How does it work conceptually? So basically I have my mission definition zone here and I have my mission execution zone there, and in this scenario I'm having 2 blue clients and 1 AI template. I have 2 red clients and 1 AI template. When I execute the mission, when you start up the mission, there is nobody on the mission, so automatically 2 AI planes will be spawned compensating the blue clients and the red clients as well. Second step is when a player is then joining that that mission, then the AI corresponding to that player will be decommissioned. On the red side, when 2 players are joining, the 2 AIs that are alive will be decommissioned, and they really will disappear unless you let them select an airbase where to return to. Now when the player leaves the scene, then immediately a new AI will be spawned at the location where the AI departs from. Yeah, so I think this is very clear. Function 2, select the return airbase. So let me illustrate this through some couple of graphics here. So you got the AI that's being spawned, there is nobody on the mission, so AI is being spawned and it has a route already lined out within the mission editor, and the AI will follow its route. So the AI is on the way. Note that when the mission has no players, the actual spawning of the AI has a time interval, so they will start at different time intervals, giving a kind of a spread of the AI active within the mission. So the AI is underway, following its route, and then let's talk about function 2.1. So when a player joins the mission, then by default, when you have when you have selected the AI to fly back to the home base, which is the target base in the route, then this will happen. Yeah, so automatically when player 1 joins, the AI will fly home and will land. Another scenario is when you select the nearest friendly airbase, and this is a bit different. So here when the AI is in the air, there is a new player spawning, then the AI will fly to the nearest friendly airbase, and notice that there's a red airbase that's been nearer, but it will fly to the blue because the airbase 2 is further away. Three. Remember the function 3, that the AI will only return if there is no enemy player in a range of that AI. So here it is. So in that sense, the AI will not return neither to its home base and neither to the nearest base, but it will continue its route and its mission. Notice in this scenario that I'm having 3 planes alive. Patrol zones. So if this is a patrol zone, and this could be any zone type, it could be a circle with a radius, it could be a polygon defined by the zone polygon class, and in the future there will be more zone types added. Yeah? For this scenario here, I have a polygon class in the form of a parallelogram. So I have 2 AIs patrolling the area, and how this works is they are flying to random points that are set within the zone, and once they reach the point, a new point will be set and flying to there. And the patrol zone class is being used by a new class. It's called the patrol zone class. Yep. So when you have a patrol zone being set and you have a AI that is out of fuel, you can ask the patrol zone to manage that situation automatically. So When the AI gets out of fuel, meaning there is a fuel percentage threshold reached, like 20% or 10% left, then the AI will contact the home airbase and a new AI will be spawned, which gets a point in the patrol zone being set to fly to. And after a specific time, so once the new AI has arrived at the patrol zone, then the old AI will fly back to the airbase for landing. Actually, the nearest friendly airbase that will be. Yeah. So what this means is that you have continuity within your patrol zone. Both the fuel threshold and the time that it will wait in the zone are specified by parameters on a method. And the fifth function is when you have two spawn objects defined for, let's say, an AI, then you can do this. So it will, the AI balancer will then select one of the two and will instantiate that. So for blue it's instantiating AI1 here, and for red it is instantiating AI template 4. Yeah. So how do we use the AI balancer? And let's talk syntax here. So the first is the AI balancer. When you instantiate it using the new constructor, it takes two parameters. It takes a client set and it takes an AI spawn object. The client set you need to instantiate with the set client object using filter criteria, and you can find the set client object description on the documentation on the web, and refer to the set training session where I have explained set unit and set group. Set client is very similar, and there is also a set airbase that we are using here later. Then local AI spawn is a normal spawn object, so you can use any group name that you have defined within your mission here. So once you have the AI balancer new being instantiated with a client set and a spawn object, then you have that entity, and it will not yet really start doing anything, but for the moment this is how you create the object. Just for information, as I said, you can have multiple spawn objects passed to the AI balancer, so you need to do this as a table of spawn objects here as a second parameter. Very simple. Yeah. Function 2.1 and 3, meaning I want to return my AI to a home base once a client is spawning, replacing my AI. So here I have my AI balancer object, and now I need to specify and use a method called return to home airbase, and I'm specifying a range. So when you call this function, when a player joins a client and the AI is airborne replacing that client, then the AI will return to the home airbase. The range specification is important because this is the range in meters that will be used to evaluate whether there is any enemy client within the range, or any enemy player within the range of the point where the AI is at the moment. And if that is the case, then that AI will not return, but it will fly on. Same for nearest airbase. So nearest airbase, you need to do something extra. As I already said, there is also a set airbase within Moose. So the set airbase is a set of all the airbases that are within the map. So you construct an airbase is set by set airbase new, and then you use filter criteria, which by the way will be most of the time here a coalition. It should be red for the red ones and blue for the blue ones in lowercase letters, and then filter start. The range again, and what you need to do here is when you want it to return to the nearest airbase, you use this function, return to nearest airbase. You specify the range, but you also then give us a second parameter, the airbase set that you've built with either blue or red airbases. Very, very simple, really. When you want to implement function 4 to let the AI patrol zones, then the first thing that we'll need to do is we'll need to explain what patrol zone is. And patrol zone is a new class as well created for the AI balancer to work with it together. And the patrol zone is actually responsible for letting an AI group execute a cap within a specified zone. The AI will fly towards a randomized point within the zone, and once that point is reached by the AI, then another point will be chosen, and it will continuously keep flying to those points within the zone until it gets out of fuel, and then it will return for landing. A new constructor creates that patrol zone, and you see quite a lot of parameters here, but it has a logic. So the first thing you need to do is to create a zone object, and the zone object is any zone class that is derived from the zone base class. So it could be zone polygon, zone radius, normally zone, and I really suggest you consult the zone documentation within Moose to understand everything about zones. There is also a training session on zones. Yeah? The patrol zone is then an object that will take that zone that you just have specified. You get a floor altitude, you specify a floor altitude and a ceiling altitude, and this means that the AI, when it's patrolling the zone, it will select a altitude point between these two values. And as well, for the speed, you need to specify a minimum speed and a maximum speed. So this means that when an AI is patrolling, it will make a variation between altitude range and a speed range. And this is really very nice. So you see the plane executing its task within the zone at varying altitudes and varying speeds. When we look further to the patrol zone class, there is another function that is there, that is, it can manage fuel. So when there is an out of fuel situation specified by an out of fuel threshold, then the AI will wait at the zone for a certain specified number of seconds until it will return to the airbase. When the out of fuel threshold is being reached, it will contact the home airbase for a replacement AI. And that AI will fly to the zone. So as we explained before. Yeah? So this is how you code this. You can modify during the patrol the altitude range and the speed range. So once a new point needs to be selected by the patrol zone class patrolling the AI, then those new values will be used. The patrol zone, when you instantiate it, it will actually not do anything because you still need to give the group for which you want to patrol the zone. So with this function here, with this method, set group, and then you give the patrol group that you have found by name or you have spawned or whatever, and it will then start patrolling that group, executing its mission within the zone with the given speed and altitude parameters. I've taken this separately because when we are executing a patrol using within the AI balancer class, then the AI balancer will actually spawn the groups within the AI balancer class, and it will use the patrol zone that you specify here to actually take the parameters of height, speed, and those things. So what it means is that within the patrol zone you may not call a set group. So when you want to have the patrol zone being given as a parameter in the set patrol zone method of the AI balancer class, then you may not call set group. It is just a reference class that's being used by the AI balancer, using its parameters to instantiate its own patrol zone objects with the parameters given. Okay, so that's it basically. There is some demo that we can go through, but I suggest we do that in a second training session, which you can find on the YouTube channel. Well, let's do a wrap-up. So basically, you can find the APIs and the descriptions on the Moose GitHub pages, which are here: flight control master github.io/moose. And here you find the documentation where you can find the patrol zone documentation. Yeah, it will be optimized, and the AI balancer documentation as well. Perfect. There's a YouTube channel where this video will be posted on. Let me show you this quickly. There are already quite some training sessions on there as well. And the other thing is, you can find example missions on the GitHub page, and these are here. And for this training session you need to look at AI Balancer. So when I click that open, I have a MIS file and a Lua file. When I click open Patrol Zone here, I have a MIS file and a Lua file. And in the Lua file you find an example of how this has been coded, and you can really play with it within the mission yourself. So same for AI Balancer. Let me show you. So this is the code for AI Balancer, having red clients, blue clients, and an AI being spawned dynamically as clients join. Great. So I think this really concludes this training session, and in a short while I will also then do a training on a demo of how, really show the training, the test missions within a video, so you don't need to execute it yourself. You can watch the video. You can reach me on Skype with the ID Flight Control Skype, or you can join the slack.com development community, where I have a Moose channel, which is here. Okay, I hope you found this interesting, and see you next time. Bye bye.